All right, today we're going to look at a third transformation rule, that being reflections. The reflections we're going to look at are over here on the right-hand side of your poster, so make sure you have your poster in front of you. Josh, there's a copy at the back because you probably forgot to pick one up yesterday. Y equals negative f of x. Y equals negative f of x is what we're going to call a vertical reflection. We'll find out why that's a vertical reflection when we get started on the exercise. So in this box right here, write down vertical reflection. And where do we vertically reflect? If we're going to reflect a graph vertically, it needs to be reflected over the x-axis. So that ties itself, that rule ties itself to the first mapping rule. Y equals negative f of x. The second mapping rule, y equals f at negative x, will pertain to what we write in the second box, and that is a horizontal reflection. Horizontal reflections, if you're going to reflect a graph horizontally, it needs to be reflected over the y-axis. Okay, so think of a reflection as basically folding a piece of paper along a mirror line. So for example, this absolute value graph up above, if we were to reflect it horizontally over the y-axis, the f at negative x rule, take a look up here. I'm going to draw an imaginary fold line here in green. And now if you folded the paper along that green line, the graph would map perfectly onto itself. So you guessed it. The horizontal reflection of this graph would just be the original graph. That would be different, though, if we reflected this graph vertically. Vertically now over this x-axis. Okay? So let's go to the practice reflection straight down below. Follow the arrows. That brings you to this sheet. Notice that I have changed the question. Cross out the f at negative x type. Cross it out and type in negative f at x. We're going to reflect that original graph vertically. Okay, so you've written that in. So now let's get ready to reflect it vertically. Notice that we created a table last day for this original graph. I've got 5 very important points on that graph. I've redrawn that table down here below. Well, think, if you reflect a graph vertically, what's going to change? The x or y values. Well, it's going to be the y values. What's going to happen to the y values? They're going to change sign. So for example, the original point of y at negative 8 was 4. If you reflect that vertically, it's now going to be negative 8 and negative 4. The original point of negative 4 is 0. Well, how do you reflect 0? Well, 0, negative 0 are the same thing, so we can't change that. The third point, 0, negative 4, well, negative 4 will now become positive 4 if you reflect that point vertically over the x-axis. 4, 0 stays as 4, 0, and 8, 4 becomes 8, negative 4. Let's take a look and see what that would look like. All right, get ready to draw in some points. Negative 8, negative 4. Would be about right there. Negative 4, 0 would be about right there. My graph's a bit tough to see, but you guys will be able to see it better on your copy. 0, 4 would be right there. 4, 0 right there. And the last one, 8, negative 4. 2, 3, 4 down. Okay, let's connect those points with a smooth curve. Starting point now is at 0, 4 instead of 0, -4. And it looks like that. Make sure that there's arrows on the end. Now you tell me, does that graph look like a perfect vertical reflection over the x-axis? Let's put it up beside the last one. I'll make that a little bit bigger. Now take a look. Does this V-graph look like the fold of the original V-graph over the x-axis? Most definitely. Okay, let's get ready to start exercise 3.2 and expand upon that rule.